Hello, let's continue our Sudoku adventure with Interlock by Riffclown. I apologize for my voice. I do have a sore throat right now, but we continue the Sudoku adventure series regardless. So this is puzzle number 501 of our series. If you missed it yesterday, I released a puzzle pack for number 500. So hopefully you saw that and are going through that at your own pace. And the video is always available if you get stuck on any of the puzzles. I did add chapters for each of the puzzles. All right. So per tradition, Riffclown has made the puzzle for number 501. He did the very first Sudoku adventure and has at least done every 50 since then. So 51, 101, 151, etc. So this continues that tradition. So let's go over the rules. It does appear to be standard Sudoku between lines and black ratio dots. If you're familiar with those, that's all you need to know. Otherwise, let's go over the rules. So standard Sudoku rules means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these between lines in the grid. So they're overlapping a bit, but you can think of them as separate lines, right? So we have two circles and then a line that connects the two circles. So this would also be two circles with a line connecting, a very short line connecting, etc., right? This, and this as well. And what that means is whatever digits we put in the circles, let's say I'm gonna go extreme here. Actually, let's not go extreme. Let's go like 2 and 5, right? Just as an example, what that means is that all of the digits on the line in between them have to be strictly in between those two digits. So they would all be 3 4s, which is not possible. But so because we can't use the 2 5 and we can't use the 1 6 because 1 and 6 are outside of the range 2 to 5, and we have to be strictly between, so we can't equal the 2 5. All right. In addition to that, we do have black dots in the grid. Black dots separate digits with a 1 to 2 ratio. So one good way to think about that is one of the digits is exactly double the other. So if this is 2, this could be 1 because 2 is double 1, or it could be 4 because 4 is double 2. We don't know the order, but we do know that one of the digits is exactly double the other. And that's it. Oh yeah, not all the dots are necessarily given. So if I put 2 4 here, there could have been a black dot. There's not. That's perfectly fine. All right. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, or you can use the tracking sheet. And I'm going to get started right now. Okay, so how do we want to get started? Well, these are very long, so we can think about how many unique digits we have to have. So this box and row, we need 3 unique digits. This box, we need 3 unique digits. This box, we need 3 unique digits. So I'd say we need 3 unique digits. Now, you can never put a 1 or a 6 on a between line because that would exclude anything from being at that end in the circle. So we are limited to 2 through 5 regardless. Now, if we're limited to 2 through 5 on this black dot, let's write it out. We can't actually do 3, 6, and 5 never pairs with anything on a black dot. We can't do 2.5, we can't do 10. So this is going to be 2, 4. And so we're definitely going to have a 1 in one of these circles, and it's going to join a 5 or a 6 is basically the conclusion we can have there. We also know this is going to be from 3, 5. And we know we need at least one of 2, 4 on the line up here. I wouldn't be surprised if it's both of them. All right, let's keep thinking about this. So how about this row here? Remember I said 1 and 6 can never go on a line? This is also a line. So we need 1 and 6 in this row somewhere. These are the only 2 places they can go. So we can fill a 1, 6 there. I bet we have more of that going on. Yeah, it should be identical down here. Yep, we have another 1, 6 pair down here. And then I think, yeah, this black dot avoids the line in this case, so we can't quite use that. Wouldn't be surprised if this 1, 6 ends up here in the circle. Wouldn't be surprising at all. Okay, so what's our next step? We need a 3 in this box, and that can only go up here. And that means there's a 3 down here somewhere. Doesn't seem immediately helpful, does it? Trying to think if this can be a 1, 6 pair. I think it could be. We can't put 1 and 6 here. I'm trying to limit 1 and 6 in this box, but not doing a good job of it. How about this box here? There we go. So these are all lines in this box. So the other 1/6 has to go here, and that's pretty big because now the 1/6 in this box goes here. So this can't be 5. This is a 1/6 pair. I'm not surprised. You should never be surprised when a 1 or a 6 goes in a between line circle. So this is not restricted other than not being 1/6. See, we could put a 1/6 in this black dot. I was trying to think if we could or not, but it's very easy to do so. So do we have anything similar going on here? This box here? Yeah, this box here needs another 1/6. Okay, so this circle here is not 1/6, so it has to be 2/5. We can't put a 3 on here. That's going to be way too restrictive, right? If we try to put a 3 here or a 4, right, it's going to be the same. Sorry, that's a fake deet, but if we try to put a 3 here, then all of these would have to be from 4, 5, 6, or from 1, 2 only. Sorry, 4, 5 only, or 2 only. Sorry, because we can't put 1/6 on them. And that's just not enough. We need 3 unique digits. So this is from 2, 5 now. And that means the other end has to be from 1/6. Because if we can't do 2, 5, and 2, 5, as we said earlier, these would end up 3, 4, and we'd have too many 3, 4s in certain rows, columns, boxes. All right. Again, I'm not going to be surprised if all of these end up 1/6. Oh, actually, no. So this 1/6 actually looks up, making this a 5. Right, and we actually, yeah, because the 1/6 pair, that ends up a 5. And so now all of these are between, this is certainly not a 6, right? So this is a 1, that's 6, and that's 6, and that's 6. That's 1, that's 1, that's 6, 1, 6. Nice. Get a 6 here. This is probably 1, but okay. This is a 3, 5 pair here. This is a 3, 1 pair. Oops. This is a 1, 3 pair, and the 1 gives us the order. That's 3 and 1. And then this is a 2, 4 pair. Okay. So sorry, just give me a second to figure out what we just got a bunch of stuff. So yeah, so we have this 5 and this 1. That's what I wanted to talk about. So these digits all have to be between 5 and 1. So they have to be from 2, 3, 4. And that makes a 2, 3, 4 triple in here, leaving behind a 1 and a 5. This is the 5, this is the 1. The 5 gives us 3 and 5. That works out. That's not a 3. Yeah, we get the 2 here, which makes sense. We weren't going to put a 5 next to a 6. So that's 2, that's 4. I think there's multiple ways through this puzzle. That's fine. This is how I'm fumbling my way through. That's a 4. We get our 2, 3, 5 here. All right. Now this is between 2 and 6. So 2 can't actually go on this line. So these aren't 2. So this is 5, 3, and 2. Similarly, that means 2 is forced here. These are all from 3, 4, 5, and we can clean that up. That's a 3, that's a 4, that's a 5, that's a 4, that's a 5. We have 2 and 4, 2 and 4, 3 and 2. These digits are 3, 6, that's 6, that's 3, and we're done. Maybe I could have used this black dot earlier, but I didn't need to. Maybe it's for symmetry. Cool. Well, I enjoyed that, Riffclown. Thank you. Nice use of between-line logic there. I liked how the black dot on the line restricted things. That was neat as well. But yeah, really nice use of forcing 1s and 6s around the grid. You just kind of had to notice which rows, columns, boxes were affected by that. So, this row, this box, not this box, this box, and this box. Very symmetric as well. Cool. Well, I hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.